Okay, guys, I've got 3 sheets of paper that I call your red notes. This is page 1. This is page 1. This is page 2. And this is page 3. And I gave those out in class. And I just want to start, honestly, on page 2. I wasn't sure where I was going to start, so I just numbered them in any order. But I do want to start with this page because it gives a great introduction. Sometimes when we're trying to solve equations, we come up with some equations that don't have any real solutions. So we have to rely on a number system with something called the imaginary unit or the imaginary number. This is indicated by the letter I. You can even find that I on your calculator. Also, we talked about this earlier in the year, but remember when you go to mode on your calculator, change it to A plus BI mode instead of real mode. And guys, you can leave it there for the rest of my class anyway this semester. You don't need to change it back to real. We can take the square root of positive numbers like square root of 9 because it equals 3. Because 3 squared equals 9. Now, technically the correct answer is plus or minus 3, but if we want the answer of negative 3, then the problem's going to say, what is the negative square root of 9, okay? So that for our purposes, square root of 9 is 3. Negative square root of 9 is negative 3. Okay, now, but we cannot take the square root of negative 9. If you type it in your calculator, it will give you an error normally. But since we changed it to A plus BI mode, we type the square root of negative 9 in our calculator. It's going to give us the answer of 3i. Okay? The reason you can't get a real solution because nothing times itself will equal negative 9. 3 times 3 won't equal 9. Negative 3 times negative 3 won't equal negative 9. So 3i times 3i will equal negative 9. And you're like, well, how will that happen? 3i times 3i equals 9i squared. Now, you're going to see in just a second that I squared equals a special number. So first of all, I equals the square root of negative 1. Okay? So what does I squared equal? Well, if you take the square root of negative 1 and you square it, the square root and the exponent cancel each other out and you get negative 1. So you come over here and you say, okay, 3i times 3i is equal to 9i squared, but I squared is equal to negative 1, so 9 times negative 1 equals negative 9. So that's the only way we can multiply something by itself to get negative 9 is to multiply 3i times 3i. Okay? Just to show you how we work this out by hand, even though you can do it on your calculator, what we say is square root of negative 121 equals the square root of 121 times the square root of negative 1. That equals 11, and this over here equals I, so the answer is 11i. Now, this one's a little tricky because you may or may not know how to do the square root of 28. Now, so I'm going to show you square root of 28 is the square root of 4 times the square root of 7 times the square root of negative 1. By the way, I can show you a trick on your calculator for getting these two numbers right here. But the square root of 4 is 2. The square root of 7, can't do anything with that, so it's just 7. And then the square root of negative 1 is I. So I've got all of this, 2 times the square root of 7 times I. How do I write that? Well, you'll see it written 2 different ways, and I don't care which way you write it. You can say that's 2I times the square root of 7, or you can say it's 2 times the square root of 7 with the I outside of the radical. Don't put it under the radical with the 7. I think most people like to write it this way because this can get a little sloppy. Doesn't matter. 5 times 2I is just 10I. Guys, you're never going to simplify I. You're going to leave it as I. You will simplify I squared because negative 6I times I is I squared. Remember, I squared is negative 1. So negative 6 times negative 1 equals 6. Okay. So here are all my answers to these problems. I'm going to pause the video. All right, guys. We might fill in some of these extra notes in class, but here's the, you should be able to do these 2 problems now. So just kind of fill in those answers on your own. I wanted to get to this little chart right here. I just equals I to the first, and so I'm just going to leave it as I. I'm not going to ever change I. But I squared, we just learned, is equal to I times I, which equals to negative 1. Okay? I to the third. Let's talk about that as I times I squared. Let's think about it that way. Well, I, we can't simplify, but I squared equals negative 1. So this is I times negative 1. So that is negative I. And then finally, let's think of I to the fourth as I squared times I squared, which equals negative 1 times negative 1. What is negative 1 times negative 1? It's 1. Okay? Now, guys, what you're going to figure out with I to the fifth is it just starts repeating back to what I equals. You say, how does that happen? Well, I to the fifth is I to the first times I to the fourth. Because 1 plus 4 is 5. Well, we already know that I to the fourth is equal to what? 1. So this is 1 times I, which is just I. So I to the first is the same thing as I to the fifth, which is just I. They're both I. I to the sixth is I squared times I to the fourth, because 2 plus 4 is 6. Well, I squared is negative 1. I to the fourth is 1. What's negative 1 times positive 1? It's just negative 1. So see, I squared is negative 1. I to the sixth is going to be negative 1. And you could guess that I to the seventh is going to be exactly the same as I to the third. I to the eighth is going to be exactly the same thing as I to the fourth. Now, guys, if you're not good with exponent rules, you're probably going to be completely lost right now. But you can ask me about it in class. So just mark on your paper, on your notes, put a big question mark by this and say, I'm going to ask him about this again in class. And I'm going to show you a trick for doing these big exponents in a little bit, but this is I to the fourth times I to the fourth times I to the fourth. That's 4 plus 4 plus 4 is 12 times I to the third, which means that that's 1 times 1 times 1. So I to the 15th is the same as I to the third, which equals what? Negative I. I to the 34th. Well, oh my gosh. That's I to the fourth 8 times. So 4, the number 4 goes into 34 8 times. So basically, if you did I to the fourth 8 times, which I'm not going to ever do this again after today. 1, 2, 3, 4, 5, 6, 7. That's I to the 32nd right there. So now I need 2 more i's. So I squared. So all of this equals 1. So just cancel all those out because that equals 1. So I to the 34th is the same as I squared, which is equal to negative 1. Okay? Pause the video. So you saw me just working on exponents a little while ago. Now, mark out this mistake that was on the paper. I fixed it last semester, but if you will divide the exponent by 4, like all of these exponents, if you'll divide them by 4 with your calculator and then look at the decimal, you'll know what the answer is. Because if the remainder is 0, then it's just then your answer is, if there's no decimal, when you divide an exponent by 4, if there's no decimal, and because the remainder is 0, you get no decimal, then the answer is 1. If the decimal is 0.25, then that equals I to the first, which is just I. If the decimal is 0.5, that equals I to the second, which is negative 1. And if the decimal is 0.75, that equals I to the third, so that is negative I. So this chart right here of what decimal you get, so divide 26 by 4 in your calculator. You're going to get 6.5. 26 divided by 4, you always divide by 4, equals 6.5. So what does the I to the 26th equal? I to the 26 equals I squared, which we know is negative 1. Okay? Divide 44 by 4, you get 11.0, no decimal. So, with no decimal, you know the answer is just equal to I to the 4th, which is 1. I to the 29th. 29 divided by 4 is 7.25. So that means it's the same thing as I to the first, which we know is just I. Then finally, 79 divided by 4, that's going to be a remainder of 3. Let's see. So we get divided by 4, that's going to be 19.75. If we divide 79 by 4, we get 19.75, which means 0.75 has a remainder of 3, so I to the third, which equals negative I. All right, guys. Can't wait to get your questions in class, and then we can get started on the homework. Okay?